Some coastlines look like accidents, others look impossible. But these three were shaped by forces so extreme they literally rewrote the edge of the continents. Coastlines are constantly changing, sculpted by the relentless push and pull of waves, the slow rise and fall of sea levels, and the dramatic shifting of the land itself. Most of the time, this process is predictable. But when glaciers, tectonics, and rising seas all collide, coastlines stop being normal and start becoming extraordinary. First, let's journey to the Adriatic Sea, to the Dalmatian coast of Croatia. From above, it looks like a barcode. Long, thin islands run perfectly parallel to the mainland, separated by narrow channels of water. This isn't your typical coastline where bays and peninsulas jut in and out. This is what geologists call a unconcordant coastline. Millions of years ago, tectonic forces squeezed this region, creating a series of folded mountain ridges that all ran parallel to the coast. Then, at the end of the last ice age, as sea levels rose, the water didn't carve new paths. Instead, it flooded the low-lying valleys between these mountain ridges. The peaks of the submerged mountains became the hundreds of islands we see today, each one a perfect mirror of the coastal mountain range. It's a coastline not carved by the sea, but drowned by it, leaving behind a unique and stunningly orderly landscape. Next, we travel north to Norway, home to some of the most dramatic coastlines on Earth, the fjords. These aren't just deep bays. They are colossal scars left behind by the Ice Age. Imagine rivers of ice, some over a kilometer thick, grinding their way from the mountains down to the sea. The sheer weight and power of these glaciers carved out incredibly deep, U-shaped valleys with steep, almost vertical sides. When the Ice Age ended and the glaciers melted, the ocean rushed in to fill these immense troughs. The result is a coastline of breathtaking inlets that can stretch over 200 kilometers inland and reach depths of over 1,300 meters, far deeper than the open sea just outside their mouths. Today, as our climate changes and the world's remaining glaciers retreat at an accelerated pace, we are witnessing the very same forces at work, reminding us that these epic landscapes are not just relics of the past, but are still evolving. Finally, we look at something that seems almost designed: the spiral beaches found in places like Half Moon Bay, California. From the air, these coastlines form a near-perfect logarithmic spiral, a shape you'd expect to see in a nautilus shell or a galaxy, not a beach. This isn't a coincidence, it's physics. When waves approach the shore, they are often blocked by a hard, rocky headland. As the wave energy wraps or diffracts around this point, it loses power and deposits sand in a predictable, curved pattern. Over thousands of years, this process sorts the sand and shapes the shoreline into a smooth, mathematical spiral. It's a beautiful example of how nature, governed by simple physical laws, can create patterns of incredible geometric perfection. These aren't random curves. They are the direct result of wave dynamics writing equations in sand. So why does understanding these strange coastlines matter? Because the forces that created them are still active today. As global sea levels continue to rise, the relationship between land and water is changing once again. Coastlines we consider normal are being reshaped, and new, unusual formations might emerge over geological time. The coastlines of today might just be the strange new landscapes of tomorrow. From the flooded mountains of Dalmatia to the glacial scars of Norway and the mathematical spirals of California, these coastlines don't just mark the edge of land. They are living records, telling the story of the most extreme and powerful forces our planet has ever unleashed. Thanks for watching.